Now that you've learned how to distinguish combination, decomposition, single replacement, and double replacement reactions, we're going to talk a little bit about how to predict whether a double replacement reaction will occur. Remember, in this class, you will only be predicting single replacement and double replacement reactions. You will not be able to predict the others. Also, you will not be predicting what the products are, just whether the reaction does or does not occur. And in this case, we're going to actually say the word go to completion. So it is known that a double replacement reaction will go to completion if any of the following are produced: an insoluble gas, water, a weak base, a weak acid, or an insoluble solid. So these are the 5 things that can tell us a reaction will occur in a double replacement reaction. Notice that these are all the products, so we'll be looking at the product side to see if any of these are produced. Also note that while we're saying that these go to completion, that doesn't mean that the other reactions do not occur at all, but what you end up with is a mess, and it's a mixture of a whole bunch of different things. So we don't normally use those for reactions. But in these cases, if you see any of these 5 types of products, those are the things that will tell you that the reaction will go to completion. That means it goes in one direction only, and most importantly, that the reaction will occur. Again, this doesn't say how fast, just that it will occur. So how we're going to use this is we're going to be observing some double replacement reactions, and we're going to look at their product side and then decide, are any of these produced? So let's first look, how do I identify an insoluble gas? In this class, the easiest way to identify an insoluble gas is to look for the parentheses G, the physical state. It will tell you it's an insoluble gas if you see that G in parentheses. The second one is easy to identify because it's water. And again, you should be able to identify water. You know that the formula is H2O. If you see H2O on the product side of the reaction, then you know that this reaction does occur. Letter C has a weak base. There's only one weak base that you in this class need to know, and that's NH4OH, sometimes written as NH3, but usually written as NH4OH, to identify it as the one weak base you need to know. So these first 3 are really easy because you just look for one thing, look for it quickly, and if it's there, then you know that this reaction does occur or go to completion. The next ones are a little bit harder. Letter D says we can find a weak acid. So now there's a lot of weak acids. One of the main things you need to do is first identify, is there an acid present? And we look for that by looking for a compound that starts with H or hydrogen. Then after that, you'll need to know the list of strong and weak acids. Of course, we don't know all of the weak acids, but we do know the 6 strong acids, which are HCl, HBr, HI, HClO4, H2SO4, and HNO3. So if you know those 6, if it starts with an H but it's not one of those 6, then it must be a weak acid, and the reaction will go to completion if it's found on the product side. The last one's the hardest one, and that's letter E, and that is, does it form an insoluble solid? So how do we know if something's an insoluble solid? And of course, to answer this, you'll need to know your solubility rules for both the salts and the bases, because those are the most likely compounds for us to look at. So what do you do if it's none of those? Well, that tells us that it would be letter F, which I haven't added here, but letter F says that there is no reaction. And that's for if it was a multiple choice on an exam, you would be given the option of one more, which says there's no reaction occurs. In reality, it means it doesn't go to completion, but we're going to say that no reaction occurs. So now let's practice that. Notice that to identify whether these reactions go to completion, first you need to know that they are double replacement reactions, and then second you need to know whether they match or make one of those 5 products. So let's first look to see, is it a double replacement? To remind you, when we look for a double replacement reaction, we're looking for 2 reactants and 2 products, and both of them should be compounds. There should be no element alone by itself. So let's look at letter A. We have 2 reactants, 2 products, and we know that this is going to be a double replacement because everything's a compound. And you'll see that everything on this page is a double replacement, so I'm not going to go through each of them individually. But now I want to focus on the products. So I'm going to cover up the reactants for a moment, and I'm going to write down the 5 things that we're going to be looking for to tell us whether this reaction goes to completion. So I've provided this list in a way to make it easy for you to identify the different ones. And I would have you do it in this order. And we're going to add one more option that you might see on the exam, and that is the letter F, which will state that no reaction occurs, or this reaction does not go to completion. I'm going to do this in a slightly different way. I'm going to look for each one by looking at the answer and seeing if I can find it on the product side. So let's start with an insoluble gas. Do any of these have a little G next to them? And hopefully you can see that letter B has H2S with a G next to it. Now if you were asked what causes this reaction to go to completion, you would circle the H2S to show what causes the reaction to go to completion. And if you were asked how do we know that this reaction goes to completion, you would say an insoluble gas forms. So that would be letter A if it were multiple choice. Next we'll look for answer B, which is water. Do you see water in any of the products? Hopefully you can see that letter C has water as a product. So the multiple choice answer would be water is formed. What is the thing that causes the reaction to go to completion would be circling water. And our next one is a weak base. Do you see anything with a weak base in it? First you'll have to remember what a weak base is, and that is the only one we have in this class, which is NH4OH, also written as NH3. And hopefully you can see that in letter D we have ammonium hydroxide, and that means that letter D has the answer of C, which is a weak base forms. And again, if you wanted to know what causes this reaction to go to completion, you would circle the ammonium hydroxide. Next, let's see if we can find a weak acid. So recall, an acid starts with hydrogen, and to show that it's weak, it has to be not one of the strong 6. So right now we can kind of eliminate a bunch of them. So we've already gotten through B, C, and D. A does not have anything with hydrogen in it. E does. It has H2CO3, and we know that that is not one of the strong ones, so that is a weak acid. So letter E will go to completion because a weak acid, the H2CO3, is formed. And next we have an insoluble solid. So do we see any insoluble solids? At this point we only have questions A and F left, so we're going to ignore the middle parts. But when we look at this, we want to look to see, do I have an insoluble gas, water, a weak base, a weak acid, any of those present? No, we don't. So now we do the hard one, which is the insoluble solid. To do this, you need to find out, is there a solid present? That you need to know your solubility rules. So we have KNO3. We know that potassium says it's always soluble. NO3 says it's always soluble. So that one is not the answer. Then we look at silver chloride. And chlorides have a solubility rule that we're supposed to have known, and that was that chlorides are mostly soluble except when they are with silver, mercury 2, or lead 2. And in this case we're with silver, so that means that this is a solid that forms. An insoluble solid is formed here, and so that is going to be your answer, is letter E. Now let's look down at letter F, and again we're going to look to see, is there an insoluble gas? No. Is there water formed? No. Is there a weak base? Well, I do notice a base, but that one's a strong base, so that one is not. Letter C. Is there a weak acid? No. That leaves us with a choice of an insoluble solid or no reaction occurs. So we're going to start with looking at the first one, which is potassium hydroxide. Potassium says it's always soluble because it's group 1A. Then we don't know about the hydroxide, but the potassium says it's always soluble because it's group 1A, and that's how we know it's a strong base. And the second thing is sodium chloride, and again, sodium says it's always soluble, and so both of these are soluble, and that means that no reaction occurs. For letter F, the answer will be F. Now it's time for you to try it. For each of these reactions, you should first decide whether the reaction does or does not occur or go to completion, and then second, if it does go to completion, indicate what causes it to go to completion. Given the choice of A, an insoluble gas is produced, water is produced, a weak base is produced, a weak acid is produced, or an insoluble solid is produced. And finally, as a reminder, if none of these are produced, then you would put down that there was no reaction. So please pause your video and then restart it when you have all of the answers done. Welcome back. Hopefully you didn't have too much trouble. We're going to start with letter A, and again we're going to only look at the products. So for this one we have the two products, NH4OH and KCl. We start off with, is there an insoluble gas? And we see there's no little g there, so there's not an insoluble gas. No water is formed. Next we look for a weak base, which is NH4OH, and there we see it. So we know that this is the reason this reaction does go to completion, is the formation of a weak base, letter C. Okay, let's move on to letter B, question B. And here we have the two products. Again, we're only looking at the products, silver chloride and sodium nitrate. So we start with no insoluble gas is formed because there's no little g, no water is formed, no base is formed at all, no acid is formed at all, so then we have to look for the insoluble solid. And according to the solubility rules, chlorides are generally soluble, but in this case it's insoluble because it is with silver, so silver chloride is insoluble. That is the reason that this reaction goes to completion. And the sodium nitrate is still soluble, but it makes no difference. So that gives us answer E as our answer for an insoluble solid forms. Now let's try question C. This one's a little bit trickier. Again, we're only going to look at the products. We see that there is no gas formed, no water formed. Is there a weak base formed? Well, some of you might have thought there was, but remember, there's only one weak base in this section of this class. We're going to talk about one weak base, and that's NH4OH. So no, there's no weak base formed. But there is a base formed. At least that's what we've told you. So why is that one the one that we're going to look at? Well, let's make sure there's no weak acid formed. The next thing is an insoluble solid. Copper 1 hydroxide is an insoluble solid. It is a base. We've been calling it a base, but it's really called an insoluble metal hydroxide. So it's not basic. It's an insoluble metal hydroxide. Its name tells you that it's insoluble, so that is an insoluble solid. So the copper 1 hydroxide is the reason that this reaction goes to completion. The sodium nitrate is still soluble, so it has no effect on the reaction. Alrighty, let's look at question D. Here we're going to look at the two products, and by checking for potassium chloride and sodium nitrate, we see that there is no insoluble gas formed, no water formed, no base at all formed, whether it's weak, strong, or insoluble, no weak acid formed at all, no acids are formed, and that leaves us with an insoluble solid. So let's look to see potassium chloride. The potassium ion is a group 1 ion, and so we know that this one is always 100% soluble. Also, chlorides are generally soluble, and potassium is not an exception, so this one is all soluble. Then we look at sodium nitrate. Everything with sodium and everything with nitrate are always 100% soluble. Normally you would not need to look at all 4 ions, and I won't ask you to. The only reason I'm mentioning that is so that you can see that nothing in here tells us that there could be a chance of any solid forming. So we know that this has no insoluble solid forming. That tells us that in this case no reaction occurs, or this reaction does not go to completion. Looking at question E, we can look at the products and see that we have hydrogen chloride and barium sulfate. First we'll look for an insoluble gas, and we do not see one. Then water, we do not see that. We do not see any bases. And next we're going to look for a weak acid. So first off, you should see that there is an acid here. But this is not a weak acid, this is a strong acid. So that is not the answer. And the last one is then to look for an insoluble solid. So we should be able to see, and when we look at sulfates, we know that they are generally soluble, but that barium sulfate is one of the exceptions. So this one will be a solid. A solid will form because it is an insoluble substance. And so the answer to this will be the reaction does go to completion due to the formation of an insoluble solid, and that will be the barium sulfate. Let's look at question F. We look at the two products and we see that we have lithium nitrate and lead 2 iodide. And so we go through the list. No insoluble gas is formed, no water is formed, no weak base is formed, no base is formed, No acid is formed, so it's certainly not a weak acid. And so we look at the insoluble solid. We see that lithium nitrate is always 100% soluble, both because of the lithium and the nitrate. And we look at the lead. There's no rule for lead specifically, but the iodide does have a rule that says iodides are generally soluble, all the halides are generally soluble, unless they are with silver, lead 2, or mercury 2. And in this case we have lead 2 iodide, and so that means that this is an insoluble solid that forms. The answer then is letter E, and the reaction does go to completion because of the formation of the lead 2 iodide. All right, let's look at question G. The two products are water and sodium nitrate. So we do not see an insoluble gas, but we do see water formed. Therefore, the answer is yes, this reaction does go to completion, and that is due to the formation of liquid water. We'll circle that one. Now let's look at question H. Our two products are hydrogen nitrite and sodium chloride. We do not see a gas forming. We do not see water forming. We do not see a base forming. We do see an acid. We have to decide if that's strong or weak. It's HNO2. HNO2 is a weak acid. HNO3 is strong, but HNO2 is still a weak acid. So we do form a weak acid in this case, and that tells us that this reaction does go to completion due to the formation of a weak acid. Also, sodium chloride is totally soluble, so we don't have to worry about that one. Now let's go on to letter I. Question I has our two products as hydrogen sulfide and sodium chloride. The hydrogen sulfide is an insoluble gas, so we're done with this question. We know that an insoluble gas forms, and so this reaction does go to completion. We also look at sodium chloride just to check, and that one is completely soluble, so we don't have to worry about it. And our last one, letter J. Here we have the two things that are produced are lithium nitrate and lead 4 bromide. So there is no gas formed, there's no water formed, no base formed at all, whether it's weak or strong, no acid formed, whether it's weak or strong, and so we look for the insoluble solid. In this case, we have lithium nitrate. The lithium and the nitrate both say 100% soluble all the time. We look at lead 4 bromide. We see that lead has no specific rules, but bromide does have some rules, and that is that it is mostly soluble unless it is with silver, lead 2, and mercury 2. In this case, we have lead 4. We do not have lead 2. So this one is not insoluble. It is a soluble solid, and so that says that both of the products are soluble, and that means that this reaction does not go to completion or no reaction occurs, and the answer will be F. I hope you were able to do all of those.